All right, so we're going to talk about Le Chatelier's principle. Le Chatelier's principle states that if we stress a system at equilibrium, it's going to shift back to relieve that stress. So we're going to look at a few cases here for a reaction N2 plus 3H2 going to 2NH3, and we're going to determine the shift if we do a few things. So N2 plus H2 goes to form NH3. Now there's a key here. We need to include states because the states are important. We also are given delta H. We'll deal with that in a little bit. All right, so the first, if I add NH3. If I add NH3, I'm adding something to the product side. So what that means is now I have too much product, so I need to get rid of that so it shifts towards the left. Okay? So it shifts towards the left, so that means I'm going to get more N2 and more H2. My NH3 is going to actually, some of that stuff that I just increased is going to go to form this. All right, so shift left. Okay, 2, if I decrease temperature. All right, so for decreasing temperature, I need to look here and I need to say, what has to do with temperature? Well, nothing does. But notice I have delta H there. I'm told delta H is negative 92 kilojoules. So that means heat is a product. Okay? Heat is product. So what happens if I decrease temperature? Basically, I'm removing some of this. So I'm decreasing a product. So that means I need to make more product. So this goes down, so that means it shifts right. Okay, 3, I add catalyst. Catalysts are not involved in a reaction. Nowhere here do I have catalyst. So that means it's going to stay, it's going to have no effect. And then number 4, I decrease volume. Now, in order to figure out the effect of decreasing volume, what I need to do is I need to look at this and say, all right, how many moles of gas do I have on either side? This is why the phases are important. So I have 1 plus 3, so I have 4 moles going to 2 moles. So if I decrease the volume, what it wants to do is it wants to get smaller. So it's going to shift towards the right. Okay? All right. Now, that's important to note that it's for gas. If for some reason, let's say this were solid, then it would be 1 mole going to 2 moles, so it actually would shift the other way. But this is for a gas, so it shifts towards the right. So left, right, no effect, and then right. All right. Okay, so there it is on the screen. You can see all it is trying to figure out what are we doing. Are we changing our product or are we changing our reactant? Okay, let's go on and let's do another equation or another reaction. We're going to look at a reaction of 2 ozone, that's O3, going to 3 O2. These are gases. All right, so we're asked, and so this is kind of a different way to look at it. The last one we were saying, hey, we do this, and what do we get from it? This one, we're trying to figure out, hey, we want this effect, how are we going to do it? Right? Okay, so in number 1, if you want to form more O2, so we want more product. So what do we want to do? We want to cause a shift to the right. Okay? So what am I going to do to volume to cause a shift to the right? So I have 2 moles going to 3 moles. If I want to shift it towards the right, I want to have it so that it goes from 2 to 3. So I want to increase the volume. Increasing the volume is going to cause this to shift right. If you're not quite sure how to do it, one thing you can do is just say, okay, if I increase volume, it shifts towards the right. If I decrease volume, it's going to shift towards the left. Okay, that means I increase volume. Okay, our second one's actually really tough. Okay, so we're told that decreasing temperature, okay, so we decrease temperature, and this caused a formation of more O2. So formed more O2, so that means I caused shift right. So decreasing temperature caused it to shift right. And so we want to know the sign of delta H. All right, so what we want to do is we want to say, well, I know there are two possibilities. Either delta H is positive or it's negative. So let's see what happens if delta H is positive. If it's positive, that means heat is a reactant. Okay. And so if heat is a reactant, that means that decreasing temperature is going to cause it to shift towards the left. Okay. Meanwhile, if delta H is negative, that means that heat is a product. So if heat is a product, and I decrease this by decreasing the temperature, that means it shifts right. So that means that delta H is negative, or it is exothermic. So basically, I go ahead, I say I want a right shift, so I figure out, okay, this will cause a left, this will cause a right, so this must be the right one. All right, here it is on the screen. We'll come back next time, and we'll talk about actually putting numbers to these changes. All right, talk to you later.